Alright, so here we have another system, and this of course is a 3 by 2 system. And so what we would like to do is go ahead and reduce it. Now remember, the thing about what we're doing here is we're just doing what we've always done. We're not really teaching you a brand new idea here. We're just kind of taking a little closer look at the solutions and seeing what it is we can see, especially in the case when we have an infinite number of solutions. There are the solutions themselves, which are always going to be expressed parametrically, have some interesting properties, especially when we understand how homogeneous systems work. So here's our 2 by 3 system and its associated augmented matrix, which if we throw this into a matrix reducer, we will get something that looks like this as the reduced matrix. And so then we see, oh look, we've got a free variable there, right? Because remember, this is an augmented matrix. This last column represents the right hand sides of our equation. Okay, so we've got our free variable. So we're going to have x sub 3 is going to be our parameter. X sub 2, or well, let's start at the top. X sub 1, working from on this row right there, is going to give us 2s minus 7. And then x sub 2 is going to be a negative 2s minus 4. So there's our solutions. If we put it in parametric form, it's going to look like this. 2, negative 2, 1, s, or plus. We'll just generally connect that with a plus, like this. And that's our solution. Now this is the point we wanted to make. Number one, if we were to look at these two pieces of the solution, this one that has a parameter and this one right here, remember what this means. The pieces that have parameters are solutions to the homogeneous system. If this was a 0, 0, then this would be its solution. Okay, and then this right here is simply one of the many solutions. In fact, it's the solution when s equals 0 to our system. All right. So maybe the big takeaway here is, like we said, the system has that formula for its infinite number of solutions, but this little piece right here is actually the solution to what the homogeneous system would be. The other interesting take on this, if we want to think about this graphically, is this is in R3, right? We've got 3 variables, so we're in 3 dimensions with an x, a y, and a z axis. And this particular equation, if you think about linear equations in R2, regular good old-fashioned algebra linear equations, we know what they look like. They look like y equals mx plus b, right? Where m is the slope, x is the independent variable, and b is the y-intercept. This happens to be one of the 3-dimensional versions of that, and so if I were graphing this parametric equation, basically what I would get is I would get a line that goes through this point. Okay, so imagine the point -7, -4, 0 in 3 space, but that line is going in this direction. So it's going in the direction of 2, -2, 1, that vector. So when you get this kind of a solution with one parametric piece, it's a line through this in this direction.